All right, we are on now the 5th video of chapter 12. We've been looking at solutions. We've been identifying what a solution is, some terminology there. We have done calculations involving solutions where you weigh a solute out and then add it to a solution to make, or a solvent to make a solution. And then we've done calculations involving dilution where you take a concentrated solution and dilute it. So now that we can do all these calculations with solutions, guess what? We can add it to our chapter, I believe this was from chapter 9, stoichiometry. We can now do calculations involving balanced reactions when you're starting with an aqueous solution. So instead of starting with grams of reactants, you can now start with volumes of reactions and its concentration to get to moles. So let's look at how this kind of works. This is kind of just should set up for you what we've been talking about molarity. Okay, so molarity will be key because we have talked about how it's a conversion factor between moles and volume. All right, so that's the top right little thing here. You can see, use the conversion factor, you can go from moles to volume pretty well. We have been doing balance equations where the balance equation tells us a mole to mole relationship. The coefficients in front, that was the mole relationship between reactants and reactants, reactants and products, products and reactants. Whatever A and B is, you can go anywhere in that balance equation. How many moles of reactant will react with another mole of reactant will produce how many moles of product. All right, so that's the mole relationship. And so in the previous chapters, we were starting with grams of reactant and then going to grams of product. But if you are not starting with a solid, but you're starting with a solution as a reactant, instead of being told how many grams, okay, was in that solution, I can now give you a volume and you can use the concentration and you can get to moles. So there are many ways to get to moles, but the key thing is you still need to get to moles to use your balance equation. All right, we'll come back. We're going to do some problems like this, but let's just give a quick little rundown. Okay, so when you are given a problem and it's talking about a reaction, so some reactants turn into products, you have to have a balance equation. If you don't, that's something you have to start with. So always start by writing an equation, correct formulas, and then balance it. All right, then for all the reactants or products, okay, you need to get whatever you're given, okay, if it's in grams or if it's in liters, you need to get to moles to use your balance equation. And then you can go between the mole to mole relationship and go and figure out, okay, if you need to go from reactants to reactants or reactants to products, you can then get to the moles of what you're trying to go for. And then in this third step, depending on what you're asked for, are you asking for grams of product? Then you use the molar mass. If you're using for a volume, well then you can use the conversion of the concentration. Or you might be given a volume and you're now solved for moles and you can find concentration. So just read carefully, figure out what you're given, what you need to go for. Ready? Let's do a practice. All right, so this question says, how could you produce 9.7 grams of PbCl2? Can you tell me what the name of PbCl2 is? All right, you should say, hey, this is an ionic compound. So you have a cation and an anion, and I can say that my cation here, the lead, is not one that always has the same charge, so I need to say it's charged. So then I look at the anion, I say, hey, that's chloride, it's a halogen, it forms a -1. There's 2 of them, so that means the lead has to be a +2. I would name it lead to chloride. All right, that's review. We are trying to produce a certain amount of lead to chloride, and our reaction, okay, the reactants, it looks like are lead to nitrate and calcium chloride. We are given a concentration of both of the starting reactants, and we're asking for how many milliliters of those starting materials do we need to add in order to, when we mix it, and we're going to make a precipitate here, we want to make 9.7 grams of it. All right, first off, what I said we had to do is write the balance equation. We are trying to produce the 9.7 grams, so that means this is going to be a product. And we can look at our 2 reactants. We are going to have the lead to nitrate. And this is a solution, all right? We're given a concentration, so its state is going to be aqueous. And we're also given a solution of the calcium chloride. So So that's also aqueous. And then we form our precipitate. So what type of reaction is this? Okay, you see two ionic compounds that are aqueous. They react, they make a solid. Okay, there's something else left over too, right? We can identify that too as well. This is going to be a double displacement or an exchange reaction. The lead was with nitrate and now it's with the chloride. That means we also have some calcium left over that's now with the nitrate. So calcium, NO3, 2. And we can also then figure out, we can use solubility rules to look up, is the calcium nitrate going to be soluble or insoluble? And if you remember your rules correctly, you would say, oh, all nitrates are soluble, which would mean this would be aqueous. So when we mix these two reactants together, we will form a precipitate, and that precipitate will be the lead 2 chloride. We want to make 9.7 grams of this product. Now, it does not tell me anywhere in here the percent yield of this reaction, so we're going to assume, in order to do this correctly, we're going to assume 100% yield. That all of the starting materials will turn into product. Now, if it gave us a percent yield, you'd have to take that into account when you figure out how much reactants you should start with. You'd have to actually add a little bit more reactants to make up for some of the product that is lost in the reaction. We'll make it easier, 100% yield. All right. Whew. We are given a couple things here. We are given the molar mass. So molar mass of the P, well, let's make a good P. PbCl2, and that's 278.1 grams per mole. And we are also told that we have a certain concentration of the lead 2 nitrate and the calcium chloride. So this is 0.100 molar. Now when you see molar, and you're going to be doing calculations with it, you want to think that means moles per liter. So instead of writing 0.100 molar, I'm writing 0.100 moles per liter. Same thing with the calcium chloride. It says it's 0.2 molar. So I'm going to write 0.200 moles per liter. All right, I think we have identified our starting numbers, okay? And if we look at this, we can see we need to go to both reactants. We're starting with the 9.7 grams. That's how much we were trying to produce. And so we have to figure out, well, what volume then of the starting materials must we add? All right, we can make our game plan, starting with your grams of PbCl2. We can do this for now, both of the reactants. We know before we can use the balance equation. Did we mention that this equation was balanced yet? Always double check. We wrote the correct reactants and products out, and I knew it was balanced already, but I didn't make that announcement. So let's double check. 1 lead on both sides, 2 nitrates on both sides, 1 calcium on both sides, 2 chlorides. So the equation's balanced, and between the reactants and all the products, it is a 1-to-1 mole ratio. All right, so that will be important here. So we can go from grams of our product to moles using the molar mass. And then once we get it into moles, we can go from moles of the product to moles of each of the reactants. So in this case, I'm actually going to go, we're going to do it 2 times, but we're going to go to moles of calcium chloride and to moles of the lead 2 nitrate. And then once you're in moles, okay, we have the conversion factor of concentration, and so we can go from moles to liters. And this will be the liters of both of those reactants. And then once we're in liters, the question asks for milliliters. So we just need to take one more conversion and go to milliliters. All right, you ready? We'll have to do it 2 times. Once we'll have to start with the product and go to the calcium chloride, and then we have to take the product and go to the lead nitrate. I might just switch up some color just to have you follow along. There is 1, 2, 3, 4 steps to each of these. The first step, let's start setting it up. We have the 9.70 grams of PbCl2. This first step is involving a conversion between moles and grams. Moles and grams, that is the molar mass of that lead 2 chloride, and it's 278.1 grams for every 1 mole. All right, once we get it into moles, we can then use the balance equation. Now we're in step 2. For every 1 mole of PbCl2, and let's go to the calcium chloride first. There will be needed 1 mole of CaCl2. And then next step, we need to go from moles of calcium chloride to liters of calcium chloride. That is relationship between moles and liters is the concentration, and that was 0.2 moles per liter. I want moles to cancel, so I'm going to put the 0.20 moles for every 1 liter. And that's up on top. And then lastly, in 1 liter, there is 1,000 milliliters. Whew, that was a bunch, okay? Grams cancels, moles of the lead 2 chloride cancel when we use the mole ratio, and then the moles of calcium chloride cancel when we divide by the concentration, and then we do the last metric conversion to go from liters to milliliters, and I end up then, if you are doing this on your own, I got 174 milliliters of calcium chloride. That was one of the reactants. We just need to do the whole same thing again, but this time use the lead nitrate. All right, same steps we've talked about. Take a second, maybe pause the video, set this up, and I'll come back and have it worked out as well. All right, I can see that my handwriting is not the best, but hopefully you can follow along with this as well. We took all of the lead chloride, okay, the 9.7 grams of it, and we converted it in the first example altogether to the volume of calcium chloride we would need to add initially. We had to figure out both reactants, so start again with the 9.7 grams of the lead 2 chloride, and now this time work it out to figure out how much lead 2 nitrate you need to use. And I got it figured out. Everything is canceling here. Grams of the lead chloride, moles of the lead chloride. When we do the 1-to-1 mole relationship here, next I use the concentration of the lead nitrate that was given at 0.1. Okay, so I divide by that, so that cancels out. I'm in liters, multiply by 1,000 to get it to milliliters. 349 milliliters of the lead 2 nitrate. Mix those two solutions together, your calcium chloride, your lead nitrate, mix them, and you should produce 9.7 grams of a precipitate, that precipitate being the lead 2 chloride. Whew, do a lot more problems working with reactions and solutions. I think you'll find them kind of fun and rewarding to get the final answer.